All right, so all quadratic equations can be solved by or via the quadratic formula that I'm about to write up here. However, we talked about two other techniques previously, the factoring method and the square root method. Those are preferred over, or I prefer them over the quadratic formula. I look at the quadratic formula as kind of the last ditch effort. If we have to, we'll pull out the quadratic formula. Now, you may like the quadratic formula, like doing that quadratic formula. If you do, that's fine. The quadratic formula will get solutions to any second degree quadratic equation. All right, so what is the quadratic formula? Well, if you have an equation ax squared plus bx plus c equals 0, so a, b, and c are playing the role of the coefficients and the constant respectively there. So if you've got, and then one side equals 0, so quadratic function just in general, then the solutions are x equals, and so does anybody want to sing it? Maybe you know a little jingle for this. I just remembered. All right, so it's negative b plus or minus square root of b squared minus 4ac all over 2a. Yeah, and so that formula you need to know. Sometimes you might, you just might have to pull that one out. Because yeah, like I said, not all, if it's doesn't work with factoring or square root method, quadratic formula will work. So that's a good thing about quadratic formula. All right, so let's look at this one. All right, so let's say we've got x squared plus 4x minus 3 equals 0. All right, so that one almost looks like we would be able to factor it. However, notice, gotta be careful, x and x, minus 3, well, you're going to go minus 3 plus 1? Well, no, because that adds up to be negative 2. You're going to go plus 3 minus 1? No, because 3 minus 1 gives you positive 2. Neither one of those. There's just nothing that'll work to give us positive 4 in the middle, negative 3 as the constant. So that's what I'm saying. Not always will factoring work or square root method, as we talked about it. All right, so yeah, we pull out the quadratic formula, which of course you got to know what the a, b, and c are to plug into the quadratic formula. And so the a here was understood to be a 1. B here is the x, so it's 4. And then c is negative 3. And of course, be sure you got one side to be 0. We do, so we're good to go. Now we just plug it into the formula. X equals, all right, so the way I look at it, it's the opposite of b. So b is 4, so you do minus the opposite of that, so be minus 4. Plus or minus, then, square root of, then you square b, so b squared would be 16. And then you got minus 4ac. I like to write that 4ac out just because there's sign issues a lot of times. Because actually sometimes, right, you might subtract actually the 16 and the 4. And sometimes you add, but other times you might add the 2. So I like to write those out just to see signs, what I've got. So it's 4 times 1 times negative 3 is what 4ac is. And then 2 times a, 2 times the 1, so that's just going to be 2. All right, so we have negative 4 plus the square root of 16. Yeah, like I said, this one actually turns out that we're going to add something to 16 because we have negative 4 times 1, but then that's times another negative. And so you wind up with positive 12. All right, so that gives us x equals negative 4 plus or minus the square root of 28 over 2. Pretty good answer. Probably not what they'll look for as the final answer. Because, like before with the square root method, a lot of times we can simplify that square root. And so that's -4 plus or minus. Let's see, looking for perfect square factors. And 4 is, right? 4 times 7 is 28. So that square root of 28, square root of 4 is 2, so you have 2 square root of 7, don't you? All right, pretty good answer as well, but last but not least here, what you look for, usually the way they want it is reduce these, well, everything but the square root. We're going to look at reducing all those numbers besides what's in the square root by common factor. And in this case, the common factor of those three things is 2. So I'm going to reduce that to -2. That's going to be 1, and that's going to be 1. So all told, what we have here is -2 plus or minus 1 squared root of 7 over 1. But the only thing we have to write, this one and this one are not necessary. We don't have to write those. So it'll be -2 plus or minus square root of 7. So there's our two answers, right? Because you got -2 plus the square root of 7, and you got -2 minus the square root of 7. You may have to write those out depending on where you're putting the answers, but yeah, those are the two solutions, and if we wanted to round them off, that's how we would. Okay? Yeah, so that's instead of last-ditch effort, we have to. All right. Now, let's say we got 2x squared minus 8x plus 11 equals 6. All right, well, once again, we need one side 0 when we're doing quadratic formula. We're factoring. It looks like maybe it could be either one, but I believe this one's quadratic formula. So yeah, we need one side 0, so you're going to subtract the 6. 2x squared minus 8x plus 5 equals 0. We could try factoring, but don't believe anything would work there. So yeah, it's going to be quadratic formula. A is 2, B is -8, C is 5 in this case. Yep. All right, so x equals -b, all right, and so, yeah, that's the way I look at -b, it means the opposite of b, so whatever b is, I do the opposite, so that's going to be a positive 8. You can write the -8 if you want to. It's still going to be positive 8. Plus or minus square root of b squared. Now, when I square -8, -8 times -8, I get 64. Yeah, the b squared, that one will always be a positive. So it's positive 64, even though it's -8. I'm squaring -8, so it's positive 64. And then -4 times a times c. You don't have to write that with those signs. Sometimes it's helpful to do. And then all over 2a, so that's all over 4. So we've got 8 plus or minus square root of 64 minus 40 over 4. Yeah, and so in this case, we are going to subtract in that square root. So we've got x equals 8 plus or minus square root of 24 divided by 4. All right, so again, pretty good answer, but we can simplify. For one thing, we can simplify that radical, square root. 24 is 4 and 6, so we got a 4 again. There's a factor, so that'd be 2 times the square root of 6. Square root of 4 is 2 times your square root of 6 will be 4. And then that's a pretty good answer, but again, simplify. Now, typically what they'll want us to do, again, like I said, except for the square root, look at the numbers in front, and you know, sometimes there may not be a common factor amongst all three of those. Here, you know, you have a common factor between 4 and 8 of 4, but you throw in the 2, yeah, the common factor amongst all those is 2. So that's typically what they're going to do, is look at all 3 and see what you can take out. So that'd be, reduce that by 2, all of them by just 2 there. So it'd be 4 plus or minus, you don't have to write that 1, square root of 6 over 2. Would be how they would want the answers there. Okay? All right. Well, let's also here, let's look at a couple of applications where we have a linear or quadratic equation or model, we might call it. Okay, so let's say we've got a model here, a linear model. Y equals 0.101t plus 1.844. Okay, so this is a linear equation, a linear model, because, yeah, we've got t to the first, and our degree is 1. Now, what this represents here, this is the number of female participants in high school athletics from 1990 to 1996. And, oh, should have added, it's the number of female participants in millions. So whatever you get here comes out in, you have to add the unit there of millions. So it's from 1990 to 96, where t equals 0 represents 1990. Okay. So yeah, your t here represents a year, but it's not the full year, 1990, 1996. T equals 0 is 1990. So if we wanted to figure out the population in 1990, we plug in, not 1990, we plug in 0 there, which I believe is the first. Okay, so my first question on this is how many female participants in 1995 in athletics, female athletics. Okay, so 1995, that's our year, but we don't plug in the 1995 because we've got t equals 0 representing 1990. So 1995, that would mean what? T equals 5? Yeah, that would be t equals 5. And so that, to get the answer here, I'm going to plug in t to be 5, so y equals 0.101 times 5 plus 1.844, right? The t is times the 0.101. Yeah, so this one's just a substitution. Just substitute t to be 5. That's, was that 0.505 plus 1.844. So that's going to mean y equals 2.349. 505? I believe so. Checking on that. All right. The answer is not 2.349, is it? No. There's more than 2.349 participants in female participants in 1995. Yeah, like I said, the y is in millions, so it's 2.349 million participants is what the model tells me were in 1995. Right? Okay. All right, now, B part to that, second part to that. All right, so if this linear model continues, so this was generated off 1990 to 1996. But let's say the pattern continues, the model continues on similar we're going to use the same value there. In which year will there be 3 million participants? In which year? Forgot. In which year will there be 3 million participants? Okay. Well, in this case, I'm trying to figure out the t, all right, the year. I'm actually trying to find the year, which is related to the t. Yeah, the 3 million participants, that's giving me a value of y, isn't it? So I've kind of switched over. Here I had t and was finding y. Now I've got y and we find t. Now, the thing about it is, though, y is not 3 million, because the y is the number of millions of female participants. So, yeah, y, if I want 3 million participants, I want the y to be not 3 million, I want the y to be 3, right? That's what that means, because that's what the model gives me, is y in millions. Yeah, so I've got y is 3, so I'm just going to plug in y to be 3, so it'd be 3 equals 0.101 t plus 1.844. So this is what I've got. And so it's just a little bit of a solving equation, solving a linear equation. And yeah, we're just going to get t on the side by itself, so same drill. Subtract the 1.844. All right, and so that gives me, use my calculator, because I don't trust myself right here, 3 minus 1.844, right? 3 minus 1.4, 1.156, yeah, equals 0.101 t. All right, so the 0.101 is times the t, so I divide by the 0.101, and that will give me 11.44. 444. I said that. All right. Now, so in which year will there be 3 million? All right, so it's wanting a year. That's years, right? T is in years, so that is years. However, let's think about that. Our years are referenced, t equals 0 is 1990. All right, so if I just add 11 years to 1990, why wouldn't that be quite what we need? This is saying I need 11 plus a little bit more to get to 3 million participants. So it's not going to happen in year 11. It's going to happen the next year, right? It's got to be 11 and then a little bit, but do a little bit, you got to just add one more year, right? So yeah, so the answer is, it'd be the 1990 plus 12, because you got to go up once, it's 11. It's not quite enough. Okay? All right, so what is that? 2002? Yeah, year 2002 would be when participants come there. All right. Well, let's look at one more model. I'll be done. All right, so L equals 0.0139 t squared plus 19.25 t plus 326.5. All right, so this is the number of lawyers in thousands from 1970 to 1996 in the U.S. T equals 0 is 1970. Okay. So, same drill. plug in, if I wanted a 1975, plug in t equals 5. May have to do that, but that would give you the number of lawyers, add the thousands. But what I want to do though is to look at one where we want to know the year again, like our previous second part over there. When will the number of lawyers surpass 1 million? When will the number of lawyers surpass 1 million? Well, okay. Yeah, so this one's even maybe a little more tricky than the second, the B part over here was, because the number of lawyers in thousands. Yeah, I've got the number of lawyers, so I've got the L value, but in this case, L is not going to be 1 because the number of lawyers is in thousands. So how many thousands is 1 million? So how many thousands is 1 million? Well, maybe you know it, you can see it pretty good, but let's just look at this. I mean, if you 5,000, you got 5 plus the 1,000, right? Or 5 times 1,000. Well, if you look at the million, 1 million, 1 and 6 zeros. Well, if you kind of think of it the same way as the 5,000, that's 5 times 1,000. Wouldn't this be 1,000 times 1,000? Yeah, so 1 million is 1,000 thousands. 1,000 thousands. Because this is the thousands part, so you got 1,000 and 1,000. All right. So that little tricky. Mention that may happen in one of the problems. So just in case. All right. So 1 million. So we don't put 1 million for L because L's in thousands. 1 million is 1,000 thousands. So L is 1,000. So that's the first one. All right. Let's move over here because I know we'll need more space. All right, so L, we're going to go with L as 1,000. 1,000 equals 0.139 t squared plus 19.25 t plus 326.5. All right, well, if we're going to solve this, you might say algebraically, that's a quadratic equation. Because we have a second degree, and I believe you'd all agree here, that's probably not going to factor. So it's going to be the quadratic formula is what it is, okay? So I need one side 0, so we're going to subtract 1,000 from both sides. So we got 0 equals 0.139 t squared plus 19.25 t, and 326.5. Is that going to be 673.5? 326.5. Check. Just to make sure. Negative 673.5. Okay? All right. Well, we've got that. Now we, like I said, quadratic formula. So my A, 139, B, 19.25, and then C is negative 673.5. So if I plug those in, the T, instead of X, we got T here. So T is negative B, negative 19.25, plus or minus the square root of B squared, 19.25 squared. Let's just write it this way. Minus 4 times A, which is 0.139, times C, which is negative 673.5. So again, we're going to be adding those up there, and then divide that by 2 times A, so 2 times that would be 0.278. Okay. So yeah, 19 plus or minus negative 19.25 plus or minus 19.25 squared, 370. I'm not going to write that. Then I'm going to do minus 19.25 squared minus 4 times 0.139 times negative 673.5. I'm just going to enter it just like that. It's 745.0285. Okay. Yeah. Well, needless to say, we're dealing with a lot of decimals here. Since I'm wanting the year, I am going to go ahead and round this off. That square root, start with the square root, is that would be rounded off to be plus or minus 27 point, let's say it's 2.295. All right, and then we've got the two answers, negative 19.25 plus 27.295 divided by 0.278, and then negative 19.25 minus 27.295 by that by 0.278. Well, I think one thing I can definitely tell here, this is not going to work because that's going to give me a negative answer. You can work it out, but that's going to give me a negative answer. I need number of years, a positive answer, so it's got to be this one. So if I take negative 19.25 plus 27.295, that's going to be an 8.045, and then divide that by 0.278. Let's see where that puts us. 28.93. So my T is what I've found here. T is 28.93. So what would that mean as far as the year goes? Well, the year starts in 1970. 28.93, so I better add 29, right, to the 1970. So that'd be 1999. All right. Questions, concerns?